Okay, now our database is get successfully created. Now we are going to launch our RDS proxy related to that database. Now our RDS instance is get successfully created. Before going to talk about the RDS proxy, let's open the Secret Manager service. What AWS does, behind the scene, it stored our credentials in the Secret Manager because we selected the option for storing the secrets in the Secret Manager. So here is the secret created by AWS by default. If we just open that secret, we got one option here for return the secret value. So we will get to know what is the username and password of that particular database. Here is the option for the rotation of the secret. So there is a rotation schedule for that current secret in the Secret Manager, which is a 7 days by default provided by the MySQL database engine. So what does that mean? Which means that after 7 days, this secret will get automatically rotated by the RDS instance. So which enhances the security. And the most important thing I want to show here that I make a big mistake in the architecture. Let me show you that diagram. Okay, this is actually I edited here. Okay, so this is our architecture which I showed you in my first video. What I think, just like Redis, we need one lambda function for AWS secrets. In that lambda function, we are going to create another function. And what does that function going to do? This function will create one random secret and store that secret in the Secret Manager. And because of this, Secret Manager is integrated with the RDS. RDS will get configured with the username and password. I think just like a Redis, but it's not like that. We are not. There is no any need of a lambda function for the AWS secrets related to the RDS, because it is integrated with RDS. It will automatically rotate the secret. In that rotation, it will contain the generation of a random password and storing the secret in the Secret Manager and configuring the same username and password with the RDS. So we just need to launch the RDS instance with the AWS secrets. There is no need to implement a rotational logic and updation of the password in the RDS instance, just like Redis. Because in Redis, we need to define here one lambda function. That lambda function will create one random password. That password will get stored into the AWS secret, and that same password will be configured with the Redis. So we need to change that architecture here. So let me just change it. It's AWS secret. Yeah, we need it. Okay, so this is our now architecture now. Because this service is integrated, RDS will take care of creation of the secret, updation of the password in the Secret Manager also, and in the RDS itself also. So this is nothing but the rotational mechanism in case of RDS. If we just click on versions, AWS provides, or the AWS Secret Manager provides us 3 types of versions: AWS current, AWS pending, and AWS previous. So what these versions are, or the staging labels? Actually, whenever the secret is get created, it will label as a AWS current. Whenever the secret is get rotated, the previous secret will label as a AWS previous, and the new secrets will label as a AWS current. And whenever there is a rotation going to happen, this secret will label as a AWS pending. If you want more information regarding these staging labels, you can go to the RDS documentation, Secret Manager documentations. And just like RDS backups, we can replicate these secrets to the different availability zone also. So this is all about the secrets and the mistakes I made, the huge mistakes I made in our architecture. Okay, no issue. I will show in the next. I will show you how we can configure the RDS proxy. Let's open the RDS proxy console here. RDS proxy option we will find the option in the RDS itself or the RDS console. Here is the option. Proxy is nothing but the RDS proxy. Just click on create proxy. Okay. Before going to explain all the options available here, I will tell you what is the importance of RDS proxy. As we discussed earlier in our architecture, the importance of RDS proxy is to creating the connection pool related to the RDS proxy. But the second most important thing about the RDS proxy is that it also reduces the failover time up to the 66%. So how does okay, so how does this possible? So whenever we say created one RDS proxy, let me select here one RDS proxy and one database instance. Okay, whenever we created the RDS proxy and one multi-agent database instance, as we all know, and that database instance contains one reader instance and the one writer instance and two reader instance here. And whenever there is a failover, in the behind the scene, what will happen? This reader instance trying to become an writer instance, but the one of the reader instance which have less replica lag, this reader instance will trying to become an writer instance. And suppose we have one application here, which is our EC2 application or any kind of applications. This application is directly connected to the RDS. So in that scenario, what will happen? This end user of this application will face some latency in their responses during that failover time. And whenever we use a RDS proxy as a middleware, what will happen? This EC2 instance will send a request to the RDS proxy, and because of this RDS proxy is internally connected to the RDS instance, this RDS proxy sends that particular request to the one of the available reader instances which have less read replica lag. So this is the internal mechanism which I read in the documentation of the RDS proxy, and this is how it reduces the time up to the 66%. So let's back to our RDS proxy console. Before that, I will just delete that. Okay. Now here the RDS proxy provides us for selecting the engine family. We are going to select MySQL engine family because our RDS instance uses a MySQL database engine. I will give here one name here, which is RDS proxy for RDS instance. Ideal client connection timeout. So what is the ideal client connection timeout? Suppose our EC2 instance or application successfully make a connection with a RDS proxy. Next time I will not delete this RDS proxy. Okay, so this is our EC2 instance and this is our RDS proxy. And this EC2 instance make a successful connection with the RDS proxy. So what will happen in some cases? This after successful connected with the RDS proxy, this EC2 instance not send any type of request to the RDS proxy and comes in the state of idle client connection. So in that case, RDS proxy will wait for a specific time to get a request from that EC2 instance in that connection only. If EC2 instance didn't send any type of request in that connection, then RDS proxy will drop that connection. I will explain you again. Suppose we define here 30 minutes, idle client connection time of 30 minutes. RDS proxy what will does? It waited for the 30 minutes. RDS proxy what will does, it waited for the 30 minutes after get successfully connected to the EC2 instance. If EC2 instance trying to make any transactions or any request, trying to send any request to the RDS proxy, it will not drop that connections. But if EC2 instance did not send any type of request or the transactions to the RDS proxy, then RDS proxy will wait for that 30 minutes, and after the successful completion of that time period, RDS proxy drops that connection and release its resources so that another connections or the another transaction, another request of EC2 instance will make a use of that connection. I will draw here the suppose here is the connected. Suppose this EC2 instance is get connected to the RDS proxy and EC2 instance holds that connections. I will select here as a medium, holds connection, right? If EC2 instance hold that connection, RDS proxy will waited for the 30 minutes only, and after the 30 minutes, it will drop that connection so that the remaining resources of the RDS proxy get released, and any other request trying to connect it to the RDS proxy will reuse that connection. So this is nothing but the ideal client connection time. So one more thing I read about the connections in the documentation of RDS proxy is that the number of times we reuse the connections in the RDS proxy, there will be the less CPU utilization on the RDS side. So which makes sense. If we reuse the connections from the RDS proxy, there will be a less CPU utilizations because the connection will not, if there is a number of requests trying to make a connection with the RDS database instance directly, this will overwhelm the database if there is any spike in our traffic, or there might be a high chances of large number of connections get opened on our RDS database instance as we discussed earlier. Second thing is that the CPU utilization will be get reduced. So this is nothing but the ideal client connection timeout. And if we just scroll down here, we can select the particular database which is the RDS, and we can define the maximum connections or the number of connections which are going to create in the RDS proxy. Suppose I specify here 100%. So I can the RDS proxy is created for the 5000 connections. It is not already created with all the connections. It will create the connections according to the traffic of our application. If we specify the 50%, it will create the connections around the 2500. Okay, I will define here one option. I will define here only the 10%, and for the ideal connections, I will leave the default settings as it is, because we are not going to test our application on the basis of connections. Okay, if you specify the 10% here, and if you remember in my previous video, we will also we already discussed about the parameter groups, and in that parameter group, I just show you the one parameter which is related to max connections to the RDS. Let me show you that also. Okay, for the RDS, we already used here the encryption, which is a custom parameter group for the SSL connection only. For now, if we just select here, search here maximum connections for our RDS database instance. Okay, so here is the dynamic value. So in that case, what will happen? If we define, there is already a maximum connections defined by our RDS instance, and here is also for the RDS proxy, it is a 10%. Then what AWS does, it will consider the average between the percentage of this RDS proxy and the number of connections available for that RDS instance. So for now, we are going to select only the 10%, and just scroll down, click on additional target group configuration. So now here we got another option for connection borrow timeout. I will explain about the session pinning filters. So first discuss about the connection borrow timeout. So this is the another timeout. First timeout is idle timeout. Second timeout is a connection borrow timeout. Okay. So what is the connection borrow timeout? Suppose our application face number of large requests, and that large, because of that large request, RDS proxies number of connection get utilized, and there is a still there is another request from the EC2 instance. Okay, I will draw one diagram here. Let me just clear it so we'll get idea here what I want to explain here. Okay, we have here a number of connections. Suppose we have number of connections, on average it is 100. And our EC2 instance have too many of traffic, or a large number of requests from the EC2 instance. So this is the large number of requests get by the end user. So what will happen in that case? This EC2 instance or the application utilize all the connections from the connection pool. Let me draw that here also. Consider this is our utilization of all the connections from the RDS proxy. And still there is a one request by the EC2 instance that try to make a connection. Okay, I will draw it as a line here also. Still there is a one request which try to make a connection with the RDS proxy, but because of there is a already utilization of all the connections from the RDS proxy, what will going to happen? In that case, that request will wait for a specific amount of time, or the RDS, or we can say in other words, RDS proxy will wait for a specific amount of time so that it connection get available in the RDS proxy pool again. So that specific amount of time we can define in the connection borrow timeout here. So this is nothing but the connection borrow timeout. The timeout which or the amount of time the RDS proxy will wait so that all the connections or the connections get freed from the application. So we can define here one connection borrow timeout, which is already defined here to 2 minutes, and it is enough for our application. So what is the session pinning filters? Before going to explain the session pinning filters, let me explain about what is the session pinning. Now I will delete this diagram. Okay. So session pinning filters, or the what is the session pinning. Before that, I will explain what happened if there is a connection, successfully connection get established to the RDS instance. Consider this is a successful connection. This is our successful connection get established. Okay, so this whole space here, this is a successful connection get established to the RDS proxy. In that connection, there is a one session here. Okay, I will draw it as a layer so that get one idea here. I will select as a rectangle here. Okay. So in that connection, there is a one session. In that session, there is a transactions. And in that transaction, there is a multiple statement. So this is our multiple statement. Statement is MySQL statement. Select start from database or any type of DDL or DML. Okay. Whenever there is a connection, there is a one session in that connection. That session contain transactions. Transaction is kind of there is also multiple transactions, single transactions, and in that transactions there is a statements. I will write down here also. So this is our connection. In that connection, we have session. So this is our session. In that session, we have multiple transactions. For now, I just draw here one transaction, okay? In that transaction, we have multiple statements. Statements like DML, DDL statements, insert, update, or any type of statement. So this is the statement. So what is the session pinning? Suppose there is a one scenario where our RDS proxy get one request from our application. That actually application makes successful connection. That connections contain one session which consists of transaction and the multiple statements. Consider there is a session in that connection. That session not able to use the another connection for executing that session only, which means that suppose this session is going to execute in that connection and there is another connection also, but because of, okay, let me just draw that connection here. This is our connection 2, and because of some reason this session or this particular session in that connection are not able to use that another connection. So in that case, what will happen? RDS proxy pins that connections to for that particular session only. So this is nothing but our connection pinning. Oh, sorry, this is nothing but our session pinning. It pins that particular connection for that session only. If you want more information, what is the scenario? What is the reason behind this session? This session cannot get not able to use another connection. You can use Llama or OpenAI. They will give you one example. Okay. To filter out the such type of connections, RDS proxy provides one option here for filtering out. So here is the option which is a session filtering, session pinning filter. We can filter out these sessions. Actually, this session is based on the variable sets. If you want more information, again, go to the RDS proxy documentation. You will get all the information related to the types of variables in the MySQL, types of in the PostgreSQL. So it's the best way to clear out all the doubts. But I just tried to explain here what is the session pinning. Next, we got another option which is a initialization query. As the name suggests, we can define one query here which we are going to initialize whenever there is a connection going to happen. Authentication, create an IAM access role. Okay. Yes, we need to create one IAM access role, or we can define our IAM access role. Behind the scene, what this IAM access role will do, it will retrieve the secret from our secret manager. Let me just open that architecture again. What this IAM access role will do? This IAM is responsible for returning the secrets from the secret manager. So this is the main use case for the IAM role. If you want, you can create your own IAM role and you can define your custom policy also, or the policy which already defined in the AWS documentation. We need to define the one secret manager here, which is already integrated with our RDS. And we need to also define here a client authentication type, which is a MySQL native password. So you might have question here, then what is this IAM authentication? This IAM authentication is for the RDS proxy. Whenever there is any end user or the connection trying to make a connection with the RDS proxy, it will authenticate on what basis? It will authenticate on basis of IAM authentication. Okay, so we want to enable that IAM authentication. No, we don't want to enable that. So we click on not allowed. If we click on allowed, again we need to implement that logic for creating the IAM authentication token, which is available for only 15 minutes. Then we can rotate that token. So this is the another scenario. But for now, we are not going to use that IAM authentication. We are going to use only AWS Secret Manager to establish a connection with the RDS and with the RDS proxy. Just scroll down here. We got the option here for require transport layer security. Okay, I will explain here the that concepts also. So the TLS is related from the, okay, so this TLS is on the application side or on the database side. Okay, I will just delete that whole diagram. Now, whenever there is a connection happen between our application, okay, consider this is our applications. Again, I deleted that shape. Consider this is our RDS proxy and our RDS. We already discussed this concept in our architecture. Okay, no issue. This is our EC2 instance. This is our RDS proxy. And as we all know, this is our RDS with MySQL database engine. And suppose there is a connection between the EC2 and RDS proxy and the RDS proxy to the RDS. Okay, this connection is called the client-side connections. And this connection is called database-side connection. Okay. So the option we get here, which is the required transport layer security, if we just tick on that, it is related to the database side connections. Okay, required transport layer security cryptographic connection is related to the database side connection. And as we all know, again in the parameter group, we defined only the SSL or the secure transport connection only, value to the 1, which is nothing but the true. So this is for the database side connections. And another thing, whenever our application trying to make a connection with the RDS proxy, just like MySQL, if you know, there is no need to define the certificate or download the certificate from application side in the application side, because RDS proxy internally fetch the certificate from the certificate manager in the AWS. So there is no need to define the certificate while communicating with the RDS proxy. If you didn't get this, what I just said, I will also show in the live demonstration where we are trying to configure our application with the RDS proxy. For now, just remember this database connection or this require transport layer security is only for the RDS proxy, between the RDS proxy and the RDS. Subnet, as we all know. Additional security configuration, yes. Here, we need to select the particular security group. So we are going to select our one security group here. Now I will also explain here the another mistake. For that mistake, I spent here about the 4 hours for just figuring out what just happened. Now consider this same RDS proxy and the RDS available in the same security group. So I will draw here as one security group. Don't confuse between the subnets and the security group, okay? So this is our security group, which is okay, not this, which allowed only the traffic on the port 3306. So what the mistake I made, I launched RDS proxy and RDS in the same security group, but whenever I check the RDS proxy availability, the targeted group inside that RDS proxy didn't get available or showing the status of unavailable. The main important reason is that the RDS proxy and RDS not able to communicate or establish a connection because of that security group, which is a 3306. And if you remember the security group which we created, which is nothing but the, let me type here our security group name also. For RDS proxy, maybe something like that, we give the name. Consider this the security group name. And let me open our security group here also. I will open the security group by using the EC2 console. So here is the security group. and okay, it's a for RDS proxy and RDS. Let me copy paste this. So this is our security group allow only the 3306, which allowed only the port which allowed the traffic from the EC2 instance on the port only 3306. Let me open that security group and I will show you. Right here. Ignore that. So here is allowed only the port of allow only the traffic from EC2 instance on the port 3306. So because of that, whenever we launch a RDS proxy and RDS in that same security group, this RDS proxy not able to communicate with the RDS because we already defined the outbound traffic related to the all types of traffic on all ports from the all ports. But there is no there is only the inbound traffic allowed for the EC2 instance only, or the EC2 instance security group. Let me draw that. We allowed only EC2 instance security group inbound traffic. Okay, I cannot draw that. I will draw here. So this is the main reason why I spent my entire 4 hours. So just figuring out what happened, what is the main reason the RDS proxy not able to communicate with my RDS instance. We allowed only the security group of EC2 instance to send traffic to the RDS or the RDS proxy security group on the port 3306. So this is the main reason. So what we need to define in inbound rules so that we can overcome that situation. So as you already notice here, we need to define the same security group as inbound group also, so that internally both the services can communicate with each other. For that, just click on edit inbound rules. I already specified here. Click add rule. It's related to MySQL, or you can type here directly 3306 and specify your security group. Now this security group name is for RDS proxy and RDS, and in the inbound rule also I will select the same security group, so that this allow the inbound traffic of itself also. So that is the main reason I spent my entire hours and not able to communicate RDS proxy with RDS. I'll just cancel that because I already defined here. Let me cross check again. Yes, it's a for RDS proxy and RDS and for EC2. Okay. So let's back to our RDS. We selected the security group. If you want any monitoring, we can activate the enhanced monitoring. But according to AWS documentation, they said only activate this enhanced monitoring if we face any type of errors. So for now, we are not going to select enhanced monitoring. Yeah, just remember from the monitoring side, we are going to also see the CloudWatch metrics also related to the RDS and for the RDS proxy, or sorry, for the EC2 instance. Now just click on create proxy. Okay, it will take some time. Okay, now our proxy is get available. I will show you the status which I am talking about. So if you click on that created proxy, just scroll down here, you will get here one targeted group. So in that target group actually contains our RDS database instance. If you click on that target group, this status, don't get confused about this status. Each status is about that database. So our RDS database is available. Yes, it's available. So that why it's showing the status of available. If we just go back, if you just scroll down, RDS is available, but that related target group is not available. So showing the status of unavailable. And as I explained here, because of this security group issue, this showing the status of unavailable, and spend my entire 4 hours again. So no issue, just wait for the few minutes. It's showing the status of available here. And if you select the another security group for RDS proxy and the RDS, then there will be no such issue. But we need to you need to define the inbound rules also for the RDS proxy and RDS. So just remember that thing. For now, just wait for the few minutes so that the target group will be get available. Okay, now our target group is available. In my next video, what we are going to do, let me open my architecture here again. Now we are done with our RDS proxy and the RDS. Now we are going to launch one EC2 application so that EC2 application can communicate with the RDS proxy and the RDS. The remaining services, the Redis and AWS Secret, Lambda, all these services we are going to create later in another videos. But for now, we are done with RDS proxy and RDS. We are going to launch EC2 application. In that EC2 application, we are going to use Node.js so that it can communicate with the RDS proxy and RDS. So just stay with my videos or stay with this playlist. I will show you how we can use the SDK or the AWS SDK, JavaScript SDK, and how we can leverage or integrate this RDS proxy and the RDS with our application. Okay, our database is get successfully created and the related RDS proxy is also successfully created. So where we are? So this is our architecture diagram. We configure one database instance with MySQL database engine and the RDS proxy. Now what we're going to do? We are going to create one EC2 or launch one EC2 application with Node.js compatibility and try to fetch some data by using the RDS. If you remember, our main goal is to check if the data is available in the Redis. If the data is available in the Redis, the application will get the data from Redis. But what if the data is not available in the Redis? Then the data will get from the RDS instance. So this is the second scenario. So we configured RDS proxy. Now we are going to connect to the RDS instance and try to get some data. Before creating Node.js application, I will explain some important things about the SSL configuration related to the RDS, which I noticed, and I just spent my entire one day because I faced too many issues related to the SSL for the RDS. So let me open my EC2 console here. I will open another tab. It's our EC2 console. I already launched one EC2 instance here with Ubuntu as OS and configured with the same security group as we discussed earlier. For the EC2 instance, I allowed all type of traffics as an inbound route just for the demonstration purpose, and for the RDS proxy, I just allowed the traffic from the EC2 instance only. I will try to connect with the EC2 instance with the session manager. If you want, you can connect by using the SSH also. But just don't forget to configure the timeout for the SSH. Okay, let me become a root here. Now, what is the command to make a successful encrypted connection between our client and our RDS instance? So why we need a encrypted connection? First point, just for the security point of view. And second thing, if you remember this, we define one parameter group here, which contain a parameter related to a require secure transport. Let me just open that. So this is the parameter group which we created, configured by launching the RDS instance. So this is the related parameter which tells RDS or the MySQL is that we accept only the encrypted connections for this RDS. So that's why we need to establish an encrypted connection between the RDS and between the RDS and the application. So where we can find this command or the driver. Before going to create one Node.js application in EC2 instance, we will execute some commands related to the SSL by using the MySQL CLI. We can find this command in the RDS docs itself. Let me just open RDS docs here. If you just scroll down here we can find the section configuring a database instance, connecting to a database instance. In that connection, if you just scroll down, we find out another section for the encrypted connections. Let me open that section. Using SSL TLS. In previous version, the encrypted connection is called by using the SSL, and the newer version, the SSL is called as a TLS. So both are the same here. We want encrypted connection for the MySQL database. Let me open in another tab. If you just scroll down, I will explain this alter user command also and what is this error. For now, just scroll down, and if you just concentrate here, we got one command for connecting with our RDS instance by making the successful encrypted connection. So I will explain this command. MySQL is for the connecting utility for connecting with the MySQL database engine. -h is defining the host or the host name. So what is the host name in our case? In our case, host name is nothing but our endpoint of the database. So in our case, we have only single endpoint because we have a single database instance. If you have multi-agent database instance, then we have endpoints like reader endpoints, writer endpoint, configuration endpoint, instance level endpoint. But for now, we have only single endpoint here. Next, we need to define the SSL CA. What is this SSL CA? This is a kind of certificate. We need to define the certificate in the command so that connection is get encrypted between the client and the application. So where we can find this certificate? Just go to the previous tab. If we just scroll down here we can find all types of certificate. If you want all certificates, you can download global bundle. But for now, our RDS proxy and our Redis and EC2 instance, all these services or the we can say applications available in that same region only, which is the AP South 1, Mumbai. So we are going to download this certificate. Okay, I downloaded here the certificate. Now, what is this SSL mode required? Actually, SSL provides 3 or 4 types of modes. Let me just show you that mode also. I will explain this diagram. Okay, so what are the types of mode? Required mode. If we define the SSL mode as a required, it allowed only encrypted connections, which means that whenever we define the SSL mode as a required in our command, and in any case or there is a scenario, there is encryption of the connection is not going to happen because of any reason, then this command will drop that connection. So this is nothing but the SSL mode required. Another mode we have which is nothing but a preferred mode, which allowed encrypted and unencrypted connection. It's just opposite of required mode, which means that if there is an error in establishing unencrypted connection, it will allow unencrypted connection also. Verify CA, which is nothing but the validate certificate. So this command ensures the certificate which we provided in our command is a valid certificate for the server side also. And the last SSL mode, which is a verify identity. With validation of certificate, it also checks the host name in that certificate for the client and for the server. Okay, before going to execute these commands with SSL mode, I will open your MySQL official user manual. So we need to go to the security. In security, we need to go to the using encrypted connections, and for configure MySQL to use encrypted connections. Encrypted connection or the certificate is already get configured to our RDS instance. If you remember, let me just show you where it is already configured. So here is a certificate authority, which is by default get configured for the RDS. And when we launch the RDS, here we can find a certificate authority, which is optional, and it's get by default selected by the AWS. So we don't need to configure on the server side, we need to configure on the client side. So here we are, the client side configuration. The same SSL mode is explained here in a client side configuration: require, disable, verify CA, verify identity, and preferred. I will explain all these modes also and what is the difference between this mode while executing the command in practical actually. So we are ready with our SSL certificate. We are ready with the SSL mode. Now what we want to do, this certificate is actually available on my local machine. So what I just did, I just create one file here named apsouth1. Let me just show you that. Nano ap south1.py, and copy paste the entire content of this file into this file. If you want, you can upload this file by using SCP or any kind of service you want. But for now, I just copy paste this certificate, which is only for that particular region, AP South1, and it is available in my root directory. Now we are going to execute this command and trying to make an encrypted connection here. MySQL -h. What is the host name in our case? The host name is nothing but the endpoint. We need to define the port here. Capital P for is define the port. In our case, username is admin. We need to define the certificate, which is AP south1.py, and we need to define the mode here. So which is the most secure mode? According to my information or according to my knowledge, the most secure mode is a verify identity. So I will going to use this SSL mode. Verify identity underscore I identity, and we need to define the password. Before going to define the password, let me just show you one. Diagram here, or the options available for the SSL mode. Let me just zoom out. Okay, it might be visible now. So encrypted. Okay. Now it is related actually to the required secure transport mode, not is SSL mode actually. The diagram is related to the required secure transport mode. In our case, for the RDS instance, the required secure transport mode is set to secure transport mode value is set to 1, which is nothing but the on, as we see in the diagram. If the state is on, we have two scenario where we can define the user defined SSL mode, or where we don't provide any type of SSL mode. So what will happen? If we define the user defined SSL mode with any kind of SSL mode like verify CA, verify identity, then definitely there will be a encrypted connections. If we didn't define any type of SSL mode, what will going to happen? This connection will use a preferred mode, and what preferred mode gives us? It gives us encrypted as well as unencrypted connection. ENCRY actually. It gives us encrypted and unencrypted connection, which we already discussed here. So let me just show you in practical. Now we are going to consider a scenario where required secure transport mode is set to on, and we will going to specify the certificate here, and we are going to use this verify identity validated certificate on host. Okay, now we are going to put the password here. The credentials of our database is already set in the secret manager. Let me just open here a secret manager. If you saw my previous video, I already explained all these rotation, versions, replications in depth. Let me just copy it and paste it here directly. Enter. Now we are successfully entered in our RDS instance. So this tells us two things. First one is that our security group is successfully transferring the traffic. And second is that the encryption is the connection between the client and the application is encrypted. And which option we used? We use the option as in the diagram, verify identity. We can use verify CA also, and we can use required and preferred mode also. How we can cross check the connection is encrypted or not? For that, I will just show you the MySQL official documentation here. Actually, they use us one command, show session status like SSL cipher. If you just paste and enter, it will give the response with some kind of value with SSL cipher, which means that the connection is the connection which we established here is successfully encrypted between the client and our RDS instance. So this is over the first case, over the require secure transport mode set to on or value equal to 1, and we define the SSL mode. But let's try to define the SSL mode with, actually here is the another mode also, which is a disable actually. As its name suggests, it disables the encrypted connection. So let's try with the disable mode. This mode is also explained by the MySQL official documentation. If you just go through it, you will get to know. Here is this. Exit. And let's try to with disable mode. Will it allow the connection? Okay, just ignore the this error. I will just copy the password and paste it here. Okay. This is not allowed the connection because connection using insecure transport are prohibited while require secure transport mode stays set to on. Which means that because our parameter in the parameter group of encryption, the require secure transport mode set to on, this connection with the SSL mode disable will not get allowed for establishing the connection. And this is the same error actually just mentioned here in AWS official documentation also, and explain here. You can set this required transport parameter, or when the require secure transport parameter is set to on of our database instance, a database client can connect to it. If you it can establish an encrypted connection, otherwise an error message. So this is the reason we get a error messages here, because we set a require secure transport mode to on and we try to make an manual unencrypted connections. So let's consider another scenario where we didn't specify any type of certificate or any type of SSL mode. What will happen? In that case, the connection will automatically consider the SSL mode as a preferred. And what is a preferred mode? It will allow the encrypted connection also and unencrypted connection also. Suppose there is an error in encrypted connection, it will allow the unencrypted connection also, which is a less secure. So let's try that also. So we just cross check the connection is encrypted. Now we are going, here we not going to specify any type of certificate and any type of SSL mode. Will this connection is encrypted or unencrypted? Now in our case, this connection will be encrypted because there is not any error in the encryption. If there is any error in the connection for the encryption, then it will use a unencrypted connection. Now we need to define the password here, specify the password here. See, now let's just try with same command. So sessions like, okay, it's uses a encrypted connection because there is not any error in our encrypted connection. If there is an error, again it will use unencrypted connection, which is a less secure. So this happens when we define the require secure transport mode to on, and with that value we define SSL mode as a user defined. It will use the encrypted connections. Or if we define without any type of, if you didn't specify any type of SSL mode or a certificate, it will going to use encrypted as well as unencrypted connection. And this is the SSL mode actually. Now let's try with the require secure transport mode set to off. For that we need to modify our database. I will just exit from the database and clear the terminal. If you remember, here we can find the parameter groups. The encryption is get configured with our RDS. Click on edit. It's required secure transport mode. We set to 0 and save changes. With the related all the related database will be get sync with our parameter groups. We just click on that databases. Here we can find the op. In the configuration, here we can find the status related to the parameter group. If you didn't know the dynamic parameters, static parameters, or what is the difference between dynamic and static parameters, just watch my previous video. Now we have to wait for some time. Okay, now our encryption parameter group is get successfully synchronized with our RDS instance. So again we are going to open this diagram. Require secure transport holds the value of 0 or have the state of off. So what we're going to do, first of all, we are going to specify the certificate in our command. So if you specify the certificate, will the connection is encrypted or unencrypted? Because the require secure transport mode is off in a off state. Let's check it. If we again execute the same command with verify identity and specify the password here. We are successfully logged into our database. Now let's check the connection is encrypted or unencrypted. See here, the connection is encrypted, which means that if we set the require secure transport mode value to off or the value to 0, and if we define the certificate and the SSL mode, then the connection is encrypted, but it is not a mandatory for our database. And in case of require secure transport mode set to on, the connection is mandatory. Okay, so this is the main difference, on state and off state. So let's execute the command without any type of certificate. Exit. Now we are going to specify. Now we are not going to specify any type of certificate here. Will the connection will be encrypted or unencrypted? Now let's check the status here. I actually make a mistake here. Here is also the connection is encrypted or in the SSL mode preferred. Okay. Now what is the state here? Require secure transport mode holds the value of 0 or it's in a off state. And if we define the SSL mode here, as we defined it here, if require secure transport mode is on. So let's execute that command with the same certificate and the same SSL mode. Will the connection will be encrypted or unencrypted? Let's cross check. So the connection is encrypted, which means that whenever the require secure transport mode state to off and any client specify the required certificate, then the connection is encrypted. Now what happened if we didn't specify any type of certificate, and if require secure transport mode is state to off? Let's get exit from the MySQL console, and now we are not going to specify any type of SSL mode here. Will the connection will be encrypted or unencrypted? So just like require secure transport mode to on, in off state also the connection between the client and RDS instance is encrypted, because it uses a SSL mode as a preferred. And we can cross check that statement in the MySQL documentation also. So here is that statement. Okay, so here is that statement. In the absence of an SSL mode option, clients attempt to connect using a encryption. Okay, without SSL mode, it will try to attempt using an encryption, falling back to an unencrypted connection, which means if there is any error, if an encrypted connection cannot be established. This is also the behavior of explicit SSL mode preferred, which we discussed in the this preferred mode, allowed encrypted and unencrypted connection. So what is the meaning of this statement? The meaning is simple. If we didn't specify any type of mode in our command, then a client tries to establish an encryption connection. If it successfully makes an encryption connection, then there will be no issue. If there is any error while establishing an encryption connection, it will make an unencrypted connection. So here you might have the one question: what is the then difference between the on state and the off state? In on state, what we see, we cannot explicitly connect by using the unencrypted connection. Let me show you here. Let me clear that terminal. And if we define here a SSL mode as disabled, actually the parameter is set to the 0, so it will allow the unencrypted connection. Now let's cross check the unencrypted connection is encrypted or not. The connection is not encrypted here, which means that if we set the require secure transport mode to off, it allows the unencrypted connection also. Suppose there is a one client which didn't specify any type of certificate. Is that okay? Yes, it is okay. But will it allow encrypted connection or unencrypted connection? It allows unencrypted connection also if the require secure transport mode set to off. But in case of require transport mode to on, it did not allow any type of unencrypted connection here. So this is the main difference between the require secure transport mode on state and the off state, or we can say 0 and 1. If you didn't get what I said, I will just conclude it in last minute. So we got one option for setting the parameters in the parameter group, which is a require secure transport mode. We can set this value to 0 or 1. 0 is set to nothing but on state, 1 is nothing but to the off, or we can say a false state. When we execute the MySQL CLI, we got options here. for the SSL mode, which is the required, preferred, verify CA, verify identity, and disabled. Required mode, as its name suggests, is allowed only an encrypted connection. If there is any error while establishing an encrypted connection, then it did not allow any type of unencrypted connection. Preferred mode, just opposite of required mode, it allowed encrypted as well as unencrypted connection, which means that if there is any error while making connection of encrypted connection, then it allowed unencrypted connection also. Verify CA, it will validate the provided certificate from the server. Verify identity, it will validate the certificate as well as the host name in the certificate also. Disable mode, we can disable the encrypted connection explicitly. So this is the SSL mode in the MySQL client. So in this two state, require secure transport mode on and off. If we specify the on state for require secure transport mode, it allowed only the encrypted connection. Suppose the user is defined SSL mode here. The by default is it will get the encrypted connection because user specify only verify CA or verify identity. And suppose if user did not specify any type of certificate, then it allowed only the encrypted connection. Because in behind the scene, what will happen? The SSL mode is set to preferred automatically because user is not set any type of SSL mode. So as a in result, the SSL mode is set to preferred and it allow only encrypted connections. If there is any type of unencrypted connections and because of preferred mode it allowed unencrypted connections, it will check the required secure transport mode state, and if its state is set to on, then it will not allow any type of unencrypted connection in that state or in this scenario. But in case of this scenario, if we specify the value of required secure transport mode to off, and we didn't specify any type of certificate on our command, it will going to consider the SSL mode as a preferred in behind the scene. And if there is any unencrypted connection or the error in an encrypted connection, it will establish a successful connection of unencrypted connection with our RDS instance. We see this example by using by explicitly setting the SSL mode disable. So this is the main difference between the require secure transport mode on state and off state. If you didn't get, again watch this video, and if you didn't find any information in this video, just go to the official documentation of MySQL and read this whole section, client side configuration for encrypted connections. You will get to know.